The next step is to build our microservice. The microservice, as previously stated, will attend the petitions from the web application and mobile application and request operations to the database. We will be building the logic in here. As a first step, we will take the tables we have configured and use a wizard to create the APIs that create, read, update, and delete registers on the tables. The wizard is launched with a right-click on the microservice from the Explorer tab and select the option Generate CRUD APIs from a relational database. A window will pop in which we can select the database from where we want to generate the operations. Next, we will see all the available tables that we imported or configured from the database. And then we select all of the tables. We can choose to only generate the APIs for a subset of tables if you want to. On the section on the right, you will see a stencil with the functions and types that the wizard will generate. For examples, the topic table will have the function names with the likes of get topics, list topics, and so on. In our case, we will leave the default options and click on Next. In the next wizard step, we will see an advanced configuration that allows to modify options on each table for things like paginations and filters. Furthermore, you can modify the suggested plural naming that is made for a table. In this case, we will modify this suggestion on the quiz table to adapt it to the plural quizzes. So we click on Edit and we modify the value on the plural section. On the next step, we will provide a path to export the elements the wizard is creating. This will keep the microservice structure easy to read and organized. So we will be leaving this option by default. And the last wizard step shows a summary of all the elements that are to be created, and you can choose to discard any new or updated change if you want to. We'll keep all of them and finish the wizard. By extending the folder structure, we can see the elements we just generated. If we click on the quiz type, we can see how it is defined, and it coincides with the table we created. We can also see that the CRUD functions were created as well. Now let's see how the wizard has implemented the update quiz function. So let's right click on it and open it. In the signature, we can see that it takes a quiz ID to identify which row to update, and it also takes a quiz object with the fields to modify. In the routing section, we can see how the API endpoint is configured, and in here we can set the root for the function. In this case is /quiz/quiz ID. The curly braces represents a parameter. The HTTP method is in this case patch. Remarks is a simple text to describe something about the function. Parameters. In here we can establish the received parameters and how they map to create the REST call. For example, we can see that the quiz ID is taken in the curly braces from the path and binds it to our quiz ID parameter. Also, we can see that the body will bind to a quiz object with the information to update. There are other options related to security and HTTP statuses, but for our example, we will be leaving all of those options by default. By doing a control click on the quiz parameter, we can see the information of the type and the system that defines it. We can click on open to edit the definition from here. In the function body, we can see the implementation of the function, that is basically a call for an update with the RDS update function, the name of the table, quizzes database.quiz, and the received information in the parameter with the circumflex character, where the field quiz ID of the table must coincide with the one we received from the function.